We all want to believe that the medicines and supplements we use are going to work, right? That they're safe and effective.
Absolutely.
But have you ever thought about like all the work and data that goes into actually making sure that's true?
That's a good point.
Well, you, our awesome listeners, have sent in a bunch of really cool info on this. Like, how do we know that those products are actually reliable, especially in these super regulated industries like pharmaceuticals and dietary supplements?
Yeah, it's fascinating stuff. And today we're going deep on one crucial piece of that puzzle: the laboratory facilities and the equipment that generate all that critical data.
Okay, so we're talking like the actual places where the science happens, right? Not just someone's basement lab.
Exactly. We're focusing on the nitty-gritty requirements set out by good laboratory practice, or GLP for short,
GLP?
and the very closely related good manufacturing practice, or GMP.
Okay, GMP, got it.
Specifically, the regulations laid out in 21 CFR Parts 110, 111, and 211.
Oh boy, those CFRs, always a fun time.
Well, luckily, you sent in some really helpful stuff to guide us.
Yeah, we've got excerpts from the Code of Federal Regulations themselves, plus transcripts from YouTube videos featuring some real regulatory experts, and even sections from these, like, authoritative books on GMP and quality systems.
Yeah, you weren't kidding about going deep.
It's not just like wiping down the lab bench, is it?
Not even close. We're going way beyond basic lab hygiene here. Our mission in this deep dive is to really break down these core GLP and GMP requirements for labs and their equipment.
Unpack it all.
We want to figure out why these standards are in place and, even more importantly, help you understand how they lead to trustworthy results.
And those trustworthy results are ultimately what guarantee the quality of the products that we use day in and day out.
Exactly.
So where do we even start with all these rules and regulations? It's a bit overwhelming.
Well, a good place to begin is with the basics. I mean, think about the lab space itself.
Okay, the physical building.
Exactly. Regulations like 21 CFR Part 110.35a are super clear. Buildings and facilities have to be kept in sanitary condition and good repair.
That makes sense. I mean, if the lab's a mess, how can you trust any results that come out of it, right?
Exactly. You can't expect precise and accurate data from a chaotic environment.
Yeah, it's like trying to bake a cake in a filthy kitchen. Disaster waiting to happen.
And it's not just about general tidiness. Section 110.20b gets into ventilation and control equipment.
Oh, right, like making sure there's proper airflow and stuff.
Yeah, to minimize odors and vapors that could mess with the materials being tested.
So even things like steam or strong fumes could impact the results.
Absolutely. It's not just about what you can see, it's the air quality, too.
Makes you think twice about those science labs in the movies, huh? All those bubbling beakers and mysterious vapors. Probably not the best for accurate results. And I remember seeing something about pest control, too. Like, you can't have rats running around your lab.
Exactly. Section 110.2007 is all about that. Screening and other measures to keep those pests out. Whether it's insects or rodents, they could totally wreck the integrity of your experiment.
So from the very start, it's about establishing a control environment. Sanitary facilities, proper ventilation, no road critters running around. All these things are crucial for preventing errors and unreliable data.
100%. A clean and well-maintained environment is the foundation for everything else.
Makes sense. You can't build a solid house on shaky ground.
And once you have the right space, you need the right tools to work with. That's where equipment qualification comes in.
Okay, equipment qualification. We saw this in the EAS Consulting Group transcript. DQ, IQ, OQ, PQ. Sounds a little intimidating.
I know, right? Like a secret code.
Break it down for us.
Well, each letter stands for a specific stage of the qualification process. First, we have design qualification, or DQ.
DQ.
This is all about making sure the equipment is designed for its intended use. Like, if you need to measure tiny amounts of something, you need a scale that can actually handle that.
Makes sense. You wouldn't use a bathroom scale to measure out ingredients for a delicate recipe. You need a more precise tool.
Right. And once you know the equipment is designed properly, you need to make sure it's installed correctly. That's where installation qualification, or IQ, comes in.
IQ.
It's all about making sure the equipment is set up according to the manufacturer's specs and the lab's specific needs. Like, is it hooked up right? Is it in the right spot in the lab?
So you can't just plug it in and pray it works. There's a whole process.
Exactly. Then comes operational qualification, or OQ.
OQ.
It checks if the instrument operates the way it's supposed to within those predetermined specifications. So you're basically making sure all the features and settings are functioning properly under normal operating conditions.
So we're confirming it's installed correctly, and now we're making sure it actually works as it should.
Precisely. And finally, there's performance qualifications, or PQ.
PQ.
This is like the final test. It makes sure the equipment consistently meets the performance standards needed for its specific application.
So can it actually produce accurate and reliable results when you use it for real tests in the lab?
Exactly. So to sum it up, DQ, right design; IQ, correct setup; OQ, basic functionality check; and PQ, consistent real-world performance.
Got it. That's a really helpful way to break it down.
Yeah, one important thing to remember is that qualification isn't a one-time thing. It needs to be done regularly, especially if the equipment is moved or if any major repairs are done.
The transcript specifically mentioned moving a big piece of equipment, like an HPLC system. Just relocating it within the lab could impact its performance, even if it seems like a small change.
Yeah, even subtle things like slight variations in airflow or vibrations in a new location can throw things off. So requalification is key to make sure everything is still working as it should. And of course, it's all documented, every single step, every result.
So there's a paper trail, or probably a digital trail these days, showing that everything was done by the book.
Exactly. These qualification processes are usually spelled out in SOPs, those standard operating procedures we talk about all the time. And the whole qualification process, everything from start to finish, is documented in these formal protocols. It's all about traceability and accountability.
So we've got our properly designed, correctly installed, fully functional, and performance-tested equipment. We're good to go, right?
Well, almost. Even the fanciest, most expensive instrument can give you wonky results if it's not properly calibrated.
Ah, calibration. That's where we make sure the instrument's measurements are accurate and traceable to a known standard.
Spot on. It's often a big part of that performance qualification or PQ stage.
Okay, so you're basically checking that the instrument is reading things correctly, right?
Exactly. 21 CFR Part 111.27 and that EAS transcript both stress that all equipment needs to be calibrated before it's used for the first time and then at regular intervals.
So you don't just calibrate it once and forget about it.
Nope, you got to stay on top of it. Now, the transcript made a good point about different types of equipment. For big stationary equipment, you go through that whole DQ, IQ, OQ, PQ process. But for smaller, more portable instruments like pH meters or balances, it's a bit different.
Right, because those get moved around the lab all the time.
Exactly. So instead of doing the full qualification shebang every time, you calibrate them more frequently, maybe even before each use or at least daily.
Makes sense. You wouldn't want to spend hours qualifying a pH meter every time you needed to check the acidity of a solution.
Right. So you've got your qualified and calibrated equipment, but just like with anything else, you got to keep it maintained. Regular maintenance is essential to making sure it stays reliable.
We're talking cleaning, replacing parts, that kind of thing?
Absolutely. 21 CFR Part 111.27C and D, along with the EAS transcript, spell it out. Routine maintenance, cleaning, and sanitization are a must for all lab equipment, and that includes replacing any worn-out or broken parts.
So it's an ongoing process to keep everything in tip-top shape. I imagine there are procedures for all this, right? You can't just clean a sensitive piece of equipment with any old soup and water.
You got it. Just like with qualification and calibration, there are documented procedures for maintenance too, usually SOPs.
Those SOPs, again, they really are everywhere in the world of GMP.
They are the backbone of a compliant system. And of course, it's all documented. Every cleaning, every repair, every part replaced.
The trusty logbook comes into play again.
You know it. Regulations require logbooks or electronic records these days to keep track of all calibration and maintenance activities. It's proof that everything was done properly by the right person at the right time. Remember, if it wasn't documented, it didn't happen.
That's a GMP mantra if I've ever heard one. And speaking of documentation, I noticed Part 110 also talked about cleaning in food manufacturing facilities, not just the equipment, but also surfaces that don't even directly touch the food.
That's right. Even those non-food contact surfaces need regular cleaning to prevent them from becoming a source of contamination. It's all about creating a comprehensively clean and controlled environment.
So it's not just about the lab itself, it's about every surface and every piece of equipment that could potentially impact the final product.
Exactly. Every detail matters when you're talking about the safety and quality of what people consume.
Okay, so we've covered the building, the equipment, the calibration, the maintenance, all the documentation. Anything else we're missing?
Well, we haven't talked about environmental controls yet. Things like temperature and humidity.
Oh, right. Those can fluctuate and mess with the stability of samples and reagents.
Exactly. You need systems in place to precisely control those factors, especially in storage areas like refrigerators and freezers.
Those are often temperature sensitive, right?
Yeah, a lot of reagents and samples need to be stored at specific temperatures. The Whitehall Training GLP webinar transcript really emphasized this point. It also highlighted how crucial environmental controls are in animal testing facilities.
So not just about the lab where the testing happens, but also the surrounding areas where materials are stored or animals are housed.
Exactly. It's all connected. And speaking of the lab layout, the amount of space you have and how it's organized is also super important.
I can see how too much clutter could lead to mix-ups or contamination, but are there actual regulations about this?
Absolutely. Regulations like 21 CFR Part 111 Subpart C and the EAS Consulting Group transcript both talk about needing enough space in the lab to prevent those exact problems, mix-ups and contamination.
So it's not just about tidiness, it's about having enough room to work safely and efficiently without increasing the risk of errors.
Right. Cramped conditions can lead to mislabeled samples, tests interfering with each other, and even cleaning procedures being less effective.
It's a domino effect. Even if a mixed up sample doesn't leave the lab, the bad data it produces could lead to a bad product down the line.
Exactly. And speaking of seemingly small but important details, the EAS transcript also brought up water quality.
Water. I wouldn't have thought that was a big deal in a lab setting.
It's actually super important. 21 CFR Part 111 says that all water used in the lab has to meet national drinking water standards at the very least. But often, you need even purer water, distilled, deionized, even ultra-pure.
Wow, so the water used in these labs is purer than what comes out of our taps at home.
Often, yes, especially for sensitive analyses. Even tiny amounts of contaminants in regular water can mess things up.
It's amazing how much attention to detail is required in these labs. And speaking of details, we've talked a lot about physical equipment, but what about the computer systems they use? All that data acquisition and analysis is done digitally these days.
That's a great point. The Whitehall Training GLP webinar transcript touched on this. Those computerized systems need to be qualified too.
So just like with the physical equipment, you have to make sure the software is fit for its intended purpose.
Exactly. Regulatory authorities want to see that the systems are reliable and secure.
And that brings us back to 21 CFR Part 11, which we covered in a previous deep dive. All those requirements about electronic records and signatures, audit trails, and data security.
Yep, it's a whole other world of regulations, but just as important. And finally, let's not forget about the test methods themselves, how the tests are actually carried out.
The EAS transcript really emphasized that. There are strict rules about how tests are performed and documented.
Absolutely. 21 CFR Part 111.303 and the EAS transcript both require that all test methods be detailed in written SOPs.
So everyone in the lab knows exactly how to do the test, step by step.
Exactly. It minimizes variability and helps ensure consistent results.
And those SOPs are needed even if you're using a standard test method from a source like the USP.
Absolutely. Even for compendial methods, you still need your own internal SOP that spells out exactly how you do it in your lab.
So it's not enough to just follow the general guidelines. You need specific instructions tailored to your equipment and personnel.
Right. And of course, every step of the testing process is documented just like everything else.
Documentation, documentation, documentation. It's the common thread through all of this.
It's the heart of GLP and GMP. If it wasn't documented, it didn't happen. And without that documentation, you can't be confident in your data.
So it's really a multi-layered system, isn't it? From the physical space to the equipment to the procedures and the documentation. It's all designed to generate reliable and trustworthy data.
Exactly. And that data is the foundation for ensuring the safety and quality of the products we all rely on.
It's pretty incredible when you think about it. All the work that goes into making sure a simple pill or supplement is safe and effective. It's a whole hidden world of regulations and procedures.
And a lot of dedicated people working behind the scenes to make it all happen.
It really makes you appreciate all those folks working in labs and manufacturing facilities. They play such a critical role in our health and well-being.
They really do.
So to recap, the big takeaways are control, consistency, and documentation, controlled environments, qualified and calibrated equipment, clear procedures, and meticulous records. It's an ongoing cycle of checks and balances to meet these strict regulatory requirements.
And at the end of the day, it's all about ensuring consumer safety and building trust in the products we use.
It makes you wonder, with all this attention to detail in the lab, what other parts of the process have similarly stringent requirements? It really highlights the commitment to quality and safety at every stage.
It's definitely something to think about. And if you're interested in learning more about the intricacies of GMP, you might want to check out our previous deep dives on SOPs and electronic records under 21 CFR Part 11. Those episodes go even deeper into this fascinating world of regulations and compliance.
It's a rabbit hole worth exploring if you want to really understand how these industries work.
Absolutely. It's complex, but ultimately it's all about protecting consumers and ensuring the quality of the products we use every day.
Thanks for joining us on this deep dive.
My pleasure. It was great unpacking all of this with you.
And to our listeners, thanks for sending in all this great information. Keep those questions and source materials coming. We'll see you next time for another deep dive into the world of GMP.
Until then.